At first glance, all rivers seem like they should look the same, flowing water moving from one place to another. Yet some appear brown and opaque, while others look almost perfectly clear. That contrast isn't random, and it isn't just about cleanliness or pollution. There's a hidden story moving inside every river, shaped by land, weather, and time. So why does one river look like stirred-up mud, while another lets you see straight to the bottom? Today we're exploring what really controls the color and clarity of flowing water, and what those differences reveal about the world beneath and around it, right here, on History of Simple Things. When a river is described as muddy or clear, the difference comes down to turbidity, which is a measure of how many suspended particles are present in the water. Muddy rivers contain large amounts of fine material such as clay, silt, and organic debris that remain floating rather than settling to the bottom. These particles scatter incoming light, giving the water a cloudy or brown appearance. Clear rivers have lower turbidity, meaning fewer suspended particles and greater light penetration. Scientists measure turbidity using instruments that detect how much light is scattered by particles in the water. Importantly, muddy water is not inherently polluted. Sediment is a natural and necessary part of river systems, helping transport nutrients and shape river channels over time. The geology of a river's watershed strongly influences how much sediment enters the water. Watersheds dominated by soft, fine-grained soil such as clay and silt tend to erode easily, especially during rainfall, contributing large quantities of suspended particles. These fine sediments can remain in the water for long distances, keeping rivers cloudy. In contrast, regions made up of harder rock types like granite or limestone break down into larger fragments that settle more quickly. Soil composition also plays a role, as sandy or gravel-rich soils are heavier and less likely to stay suspended. Vegetation further affects erosion by stabilizing soil with root systems. As a result, rivers flowing through forested or rocky landscapes are often clearer than those draining broad agricultural plains or sediment-rich lowlands. A river's speed and volume determine how much sediment it can carry. Fast-moving water has more energy, allowing it to lift and transport particles from the riverbed and banks. During periods of heavy rain or snowmelt, rivers often appear muddier because increased flow stirs up sediment and keeps it suspended. When water slows down, gravity causes heavier particles to settle to the bottom, improving clarity. This is why calmer sections of a river often look clearer than narrow channels or rapids. As rivers spread out across floodplains or widen near their mouths, their reduced speed causes sediment to drop out, forming sandbars and deltas. Seasonal changes in flow mean a single river can shift between muddy and clear conditions throughout the year. Weather plays a direct role in determining how much sediment enters rivers. Heavy rainfall generates surface runoff that carries soil, organic material, and debris into streams and rivers. Regions with frequent or intense storms often have muddier rivers, while areas with steady, gentle rainfall experience less erosion. Seasonal climates further influence clarity, as wet seasons usually bring higher turbidity. In colder regions, spring snowmelt can rapidly increase sediment loads over a short period. Climate change is altering these patterns by increasing the frequency of extreme rainfall events in many regions, leading to stronger erosion pulses. At the same time, droughts can reduce vegetation cover, leaving soil vulnerable when rain eventually returns, further affecting river clarity. Human land use has become one of the most significant influences on river turbidity. Activities such as deforestation, agriculture, mining, and construction disturb soil and remove vegetation, making erosion more likely. Urban development adds paved surfaces that increase runoff speed, allowing more sediment to be carried into waterways. Agricultural practices can contribute both sediment and nutrients that alter water appearance. On the other hand, conservation measures like reforestation, erosion control, and protected river buffers reduce sediment input. Dams and reservoirs trap sediment upstream, often producing clearer water downstream while disrupting natural sediment delivery. These changes show how human activity can reshape river behavior far beyond the immediate area. Not all cloudy water is caused by mineral sediment. Biological and chemical processes also affect river appearance. Algae and microscopic organisms can multiply when nutrients are abundant, reducing clarity and changing water color. Organic matter from decaying leaves and plants can darken water without increasing sediment load. Some rivers appear tea-colored due to tannins released from wetlands and forest soils, even though they may contain little suspended sediment. Chemical reactions can also form fine particles, such as calcium carbonate precipitates in hard water rivers. These factors demonstrate that clear water is not always chemically simple, and cloudy water is not always unhealthy. Whether a river appears muddy or clear depends on how water interacts with land, climate, and living systems along its path. Soil type, geology, flow speed, weather patterns, human activity, and biological processes all influence what we see at the surface. Muddy rivers often transport essential nutrients and reshape landscapes, while clear rivers reflect conditions where particles settle or are filtered out. Neither state is inherently better. Each tells a story about its environment. By understanding river clarity, we gain insight into the forces shaping waterways and the landscapes they connect, revealing that even something as simple as watercolor carries a deeper natural history. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.